Can I have some water?
Yes, sure.
Thank you.
Welcome.
Why is it empty?
Oh, sorry, I forget to refill.
It's okay lah. Let's go, we refill together.
Okay, let's go.
Yes, can I help? Bro, why is the water is so slow?
Oh, usually this flowing speed of water flowing out is like 5 centimeter cube per second.
Wow, this is really cool information.
How about we ask madam? How long for this bottle to fill up?
Okay, let's go.
Okay.
Hi miss, can we ask you some questions?
Sure, what is it?
Miss, how long it will take for the water to fill up if the rate of the water flowing in is 5 centimeter cube per second?
I can help you, but before that, I need to know what is the height of the water and the radius of it. Do you know?
Yeah, I know. Here, let me help you. I'm an expert at this. The diameter is about 12 centimeter. Can you put it down?
Yeah.
And the height is about 28 centimeter. I'm great at the rulers, right?
Yeah.
It's so rude.
Thank you for helping them.
Thank you.
Before I explain this problem and how to solve it, let's see this slide first.
Application of differentiation. In calculus, differentiation is one of the two important concepts apart from integration. Differentiation is the process of finding the derivative of a function, which represents the rate of change of the function value with respect to a change in its input. The process of differentiation involves the use of various differentiation rules, such as the power rule, the product rule, the quotient rule, and the chain rule to find the derivative of a given function. By finding the derivative, we gain insight into the behavior of the function, determine the maximum and minimum point.
Related rate is a rate of change associated with two or more related quantities that change over time. The problem is solved by finding the rate of change of one quantity by relating it to another quantity whose rate of change is now. For example, when a spherical ball is filled with air, both the volume and the radius increase. Then, dV over dt and dr over dt are related rates because V is related to R.
Problem statement case 1. We need to determine how long it will take to fill a cylindrical bottle with a height of 28 cm and a radius of 6 cm using a constant water flow rate of 5 cm cube per second. This calculation is essential for understanding the duration required to fill the bottle completely. For the solution, we bring out all the information that we get, which is R equal to 6 cm, H equal to 28 cm. And then we substitute R equal to 6 into the formula volume of cylinder. And then we will get V equal to 36 pi H. And then we differentiate the V, we will get dV over dH equals to 36 pi. From the information we get the dV over dt equals to 5 cm cube per second. And then we must find dH over dt using chain rule, which is dV over dt equals to dV over dH times dH over dt. So we substitute all the information to the equation. So we get the 5 equals to 36 pi times dH over dt. dH over dt equals to 5 over 36 pi equals to 0.044 cm cube per second.
Let's move to the problem statement for case 2. An ice cube in the shape of a cube is melting in a bottle at rate of 1 cm cube per second. There's a total of 15 cubes and each side of the cube is x plus 1 cm. We need to find three things, which is total surface area, total volume of the ice cube, and we need to find the rate of change of the surface area of the ice cube when x equal to 2 cm. For the first question, A. Find the total surface area of the ice cube. It is given in the question just now. the side of each cube is x plus 1 centimeter, and there's 15 total of ice cubes. So first we need to find the area of the cube, which is 6 times with x squared. We substitute the x, which is 6 times with x plus 1 squared, and we will get 6x squared plus 12x plus 16. And the total surface area, we time the area with 50, and we will get 90x squared plus 180x plus 90. Next question, B. Find the total volume of the ice cube. The formula to find volume of cube is x cubed. We substitute x, we get x plus 1 cube, and we will get the answer is x cubed plus 3x squared plus 3x plus 1. And the total volume, we times the volume just now with 15, and we will get 15x cubed plus 45x squared plus 45x plus 45. Last question, C. Find the rate of change of the surface area of the ice cube when x equal to 2. First thing first, we need to list out all the information that we get. Just now, in the problem statement, it is given that the rate for an ice cube to melt in a bottle is 1 centimeter cube per second. And based on the question, we need to find dA over dt and x equal to 2. But carefully, dV over dt is equal to negative 1 centimeter cube per second. Why negative? It is because of the word melting. To find dA dt, we need to create an equation. So dA over dt is equal to dA over dV time with dV over dt. But before that, we need to find dA over dV first. So dA over dV is equal to dA over dx time with dx over dV. Based on this equation, we need to find first derivative for area and volume. Just now, we get that A is equal to 90x squared plus 180x plus 90. So the first derivative for it is 180x plus 180. And for volume, we get that 15x cubed plus 45x squared plus 45x plus 45. And the first derivative for it is 1 over 45x squared plus 90x plus 45. Now, we need to times both of it. We will get 180x plus 180 over 45x squared plus 90x plus 45. Now, after we find dA dV, we finally can get dA over dt. So we substitute dA over dV and dV over dt to the equation. To the equation dA over dt equal to dA over dV time with dV over dt. So we will get that negative 1 time with 180x plus 180 over 45x squared plus 90x plus 45. We then substitute x equal to 2 inside the equation, and final answer we will get negative 4 over 3 centimeters squared per second. That's all.
Lastly, for the conclusion, the problem in which the speed of change of the height of the water in the bottle has been successfully solved by using the differential applications. We have learned that the rate of change of the water level in the bottle is 0.044 centimeter cube per second, and we get to solve the problem of the melting ice cube by finding the rate of change the ice cube melt, which is negative 4 over 3 centimeter square per second.
Yes, but I think this is too complicated. How about you just go buy some water